We're going to cover two learning targets. The first one, I can multiply monomials, and then I can multiply a polynomial by a monomial. So what you need to know, we're going to do a quick review on the difference between adding polynomials and then multiplying polynomials. So here's a couple examples. On the left here you can see I have 3 plus 4. Then on the right I have 2 to the third times 2 to the fourth. So let's visually look at the difference here. On the left, when I'm adding 3 plus 4, I'm simply adding 3 items, 1, 2, 3, to 4 items, 1, 2, 3, 4, which would give me a total of 7 items. On the right, I'm multiplying the same number by itself, however many times I'm raising my exponent to. So 2 to the third is 2 times 2 times 2. 2 to the fourth is 2 times 2 times 2 times 2. So I've done that a total of 7 times. So this would become 2 to the 7th. Here you can see when we multiply, we are adding our exponents. So let's look at an example where we have variables involved. When I'm adding 3r plus 4r, I'm literally adding 3 r's, 1r, 2r, 3r's, plus 4 r's. That would give me a total of 7 r's. As opposed to when I'm multiplying my r's, here I have 3 r's times 4 r's. I now have a total of 7 r's, so I can write that as r to the 7th. Again, we've taken our two exponents and we've simply added them together. So let's look at an example where we multiply the polynomials. So in this first example, I have 2x squared all times 3 times x cubed. First thing we want to do is we want to find our coefficients. Those are the numbers out front, the 2 and the 3 that I've highlighted here. Next, we look at the variable parts that are the same. So x and x are the same variable part, and I multiply them together. So x squared times x to the third. We know that 2 times 3 can be put together because those are like items, and then my x's can all be combined. So if I were to write all of this out, I'd have x times x from this first x squared, and then I'd have my last 3 x's from my second x term here, x cubed. That would give me a total of 6x to the 5th. Another example, this one's got a little bit more detail. I have 7 times x squared times y to the 5th, and then times 9 times x to the 3rd times y. So again, we're going to highlight the parts that are the same that I can combine. So the 7 and the 9 are my coefficients, and then we look for the variables, the same letters. So x squared and x to the 3rd, and then I look at my y's. I have y to the 5th and y, and I put it all together. So I've got 7 times 9, then I have x squared times x to the 3rd, and then my y's, y to the 5th and y. Remember, when we are multiplying our variables, we add our exponents. So this is going to turn into 63 because 7 times 9 is 63. X squared times x to the 3rd, I add the exponents, I get x to the 5th. And then here I have y to the 5th times y. Remember, this is really like y to the 1st, so 5 plus 1 gave me 6. That's how I got that final answer. Now, the examples we just did were two monomials, or single terms, multiplied by one another. But what happens when we have a monomial out front that's being multiplied by a polynomial? In this case, I have a binomial because there's two terms inside of my parentheses here. So hopefully you notice that because I have parentheses here, we're just going to use the distributive property. I'm going to multiply that 4 times the 5a, shoot my rainbows through. So 4 times 5a is just 20a. And then 4 times 7, I shoot that second rainbow over, is 28. So this simplifies to 20a plus 28. I cannot combine them any further because they are not like terms. Now what happens when I have a monomial out front that has a variable with it? Here I have 3 times n squared. We're going to do the same thing. We're going to start by multiplying the term out front by the first term. So I combine the parts that are the same. 3 and the 8 give me the 24. N squared times n squared, remember we add our exponents. 2 plus 2 gave me 4. Then we continue. Now I multiply that monomial out front by my second term. 3 times 5 gives me that 15. N squared times n, remember this is really n to the first. 2 plus 1 gives me 3. And then lastly, 3n squared all times negative 8. 3 times negative 8 gives me this negative 24. I don't have any other variable parts in this third term, so I just break down the n squared. I can't combine any of these like terms, or any of these terms, because they're not like terms, because I have n to the fourth, n to the third, n to the second, so that is my final answer. Right now would be a great time for you to pause and then give these problems a try. So the first one, 4x to the third times 2x to the seventh. I'm going to highlight my coefficients, those are the numbers out front, and then I'm going to highlight my x's. 4 times 2, I put those together, and then I put all my x's together. You don't have to write all of your x's out, but this is just that visual. So 4 times 2 is 8, and I have 10 x's, so x to the 10th, when I multiply them together. Notice all we did were add our exponents. So x squared times x to the 7th can also be written like this, x to the 3rd plus 7, which is x to the 10th. That's what's happening here. All right, in this next example, I have 9 times x squared times y to the 9th, and that's all times negative 10 times x to the 3rd times y to the 5th. Again, we're going to go ahead and color code. So we have our coefficients out front, 9 times negative 10. I've got my x terms, y squared, x squared, and x to the 3rd. And then lastly, my y's, y to the 9th and y to the 5th. So this, when I kind of group them, I will just rewrite it grouped. So 9 times negative 10 is going to give you that negative 90. X squared times x to the 3rd, we add our exponents, that turns into x to the 5th. And then y to the 9th times y to the 5th, I'm going to go ahead and combine those exponents by adding them as well. So 9 plus 5 gives me 14. Again, when I have a monomial out front, just a single coefficient, we're going to go ahead and distribute that through. So 5 times 5n gives me 25n, and then 5 times negative 2 gives me negative 10. They are not like terms, so we're done. Another example here, this time I have a monomial of 6n to the 5th. So when I multiply that through, we multiply those number parts together, those coefficients. 6 times 5 gives me the 30, and then we combined our variables here by adding our exponents. N to the 5th times n to the 2nd gives me n to the 7th. Middle term, 6 times negative 7 is giving me that negative 42, and then n to the 5th times n to the 1st. Don't forget, when you don't have that variable, or when your variable doesn't have an exponent, it's really to the 1st power. So 5 plus 1 gives me this 6 right here. And then lastly, 6n to the 5th times 1. That doesn't change anything, it just stays 6n to the 5th. None of these are like terms, so that's my final answer. If you need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.